What's going on, everybody? My name is Nate. Welcome back to Read Derived, and today we're going to be tackling some practice problems for one-dimensional kinematics. So without further ado, let's get right into it.
Run away with me.
Okay, so here's our first problem. Let's read it out loud. Bill leaves New York City at 10 a.m. to drive to Albany, 300 miles away. He travels at a steady speed of 50 miles per hour. Rachel leaves New York City at 10:30 a.m. and drives at a steady speed of 60 miles per hour. Who gets to Albany first? Well, this is only going to use one equation. So let's first write down our definition of velocity. Average velocity. Got average velocity equals delta x, which is displacement, over delta t. So what does this reduce to? Let's expand this. Delta x is the same thing as saying the change in displacement, so that's just final displacement minus initial displacement over final time minus initial time. Let's also write down the variables that we know. I'm just going to make a chart for Bill, and I'm going to make a chart for Rachel. I find defining these variables in terms of little charts like this makes it a lot easier. So for Bill, we know that he leaves New York City at 10 a.m. So our initial time is 10 a.m. Okay? And of course, that's t sub I. Okay, our change in displacement, delta x, is 300 miles. And our average velocity for Bill, I'm just going to say v sub b, and I'll say sub b for Bill for all these, equals 50 miles per hour. 50 mph. All right, let's define our variables for Rachel now. Rachel leaves New York City at 10:30 a.m. So t sub I, r, for Rachel, equals 10:30 a.m. All right, she's traveling the same distance because she's leaving from New York City and they're going to the same place. So delta x r equals delta x b, which we'll just call delta x, which of course we have already defined to be 300 miles. 300 miles. And now for our average velocity, which in the context of this problem is the same thing as speed because they're going in the same direction. So we're just going to define our coordinate system to be in the positive direction leading from New York City to Albany. V sub r equals 60 miles per hour. So now I'm just going to rearrange this equation and solve for TF because we're trying to find who gets to Albany first, which is our final destination. So we need our final time. So I'm just going to do some algebra and solve for T sub F. But I'm going to use a different marker. I'll use black. V bar sub B equals XF minus XI all over TF minus TI. And like I said before, let's just solve for T sub F. So I'm going to multiply both sides by T sub F minus T sub I, T sub F minus T sub I, and these cancel. So now we have V bar sub B times TF minus TI equals XF minus XI. So now let's divide V bar to the other side. Divide by V bar, divide by V bar. Of course, these cancel. And now we have TF minus TI equals XF minus XI over V sub B. And last step, we're just going to move T sub I to the other side. Plus T sub I plus T sub I. T sub F equals XF minus XI all over V bar sub B, because we're solving for Bill right now, plus T sub I. Okay, now let's just plug in our numbers and see what values we get. T sub F equals XF minus XI is the same thing as change in displacement. So I'm just going to substitute this value in for our numerator over here. 300 miles over v bar sub b, which we define to be 50 miles per hour, mph, plus t sub I, which of course is 10 a.m. 10 a.m. Okay, what does this give us? T sub f equals 300 over 50 is just 6. Miles cancels with miles, so then we just get hours. 6 hours plus 10 a.m., which is our initial time. And I know the units look weird here, but 6 hours plus 10 a.m. is just going to bring us to 4 p.m. So I'm just going to write the final answer over here. T sub f for Bill equals 4 p.m. All right. Not bad. And now let's solve for Rachel. And I'll rewrite my equation. Okay, let's plug our values in for Rachel and see what we get. T sub f equals xf minus xi. Again, they're driving the same distance. 300 miles over v bar sub r for Rachel. And the average velocity for Rachel is, of course, 60 miles per hour. 60 miles per hour plus our initial time for Rachel, which in this case is 10:30 in the morning. Okay, let's solve it. TF, 300 miles over 60 miles per hour. Miles cancel. Our units just end with hours. We get 5 hours plus 10:30 a.m. And of course, this brings us to 3:30 a.m. T sub f equals 3:30 p.m. p.m. Okay, so let's write this over here so we remember what we got so I can erase the board. So what's the answer to the question? Who gets to Albany first? Well, it's whatever time is lower than the other person because that means they got there first. So Rachel got there first and she got there half an hour before Bill. All right, so the answer to part A is, of course, these two values and who gets to Albany first. We decided it was Rachel. And for part B, how long does the first person to reach have to wait for the second to arrive? Well, 30 minutes or half of an hour. That's the end of the video. I really hope you enjoyed watching me solve these problems. I find watching people solve problems really helps me solve problems and get better at solving problems. So in the next few weeks, I'm going to be posting a lot more problem solvings and problem solutions to make Rederived your one-stop shop for everything physics. So thank you and goodbye.
I was just calling to see if you're free.